Welcome to the DIY Honda Garage channel. The DTC P0235-17 indicates a high voltage condition in the turbocharger boost sensor circuit. This particular fault is crucial because the turbocharger boost sensor plays an important role in the vehicle's engine management system. It measures the boost pressure generated by the turbocharger and sends the data to the powertrain control module, PCM. When the boost sensor output voltage exceeds a specified threshold, it triggers the PCM to store this diagnostic trouble code, DTC. The PCM then takes necessary actions to protect the engine and maintain performance integrity. Understanding this error is the first step in addressing potential issues within the turbocharger system. The error relates primarily to the turbocharger boost sensor, which is responsible for measuring the pressure of the air entering the engine after being compressed by the turbocharger. This sensor is typically located near the turbocharger itself and is connected to the PCM. The PCM analyzes the signals it receives from this sensor to adjust engine parameters for optimal performance. A high voltage output signal from the sensor indicates a malfunction that could compromise engine efficiency and performance. The inspection involves checking the integrity of the boost sensor, the wiring, and the PCM connections to ensure proper functionality and pinpoint the source of the problem. Several potential issues could lead to the DTC P0235-17. One common cause is a high output voltage from the turbocharger boost sensor itself, which may suggest that the sensor has failed or is malfunctioning. Another possible cause is a faulty connection in the wiring that conducts signals between the sensor and the PCM. Open circuits, where the electrical connection is incomplete, can disrupt the signal flow and trigger this DTC. Diagnostic checks are crucial to identifying the root cause by assessing the sensor output voltage and examining the wiring integrity connecting the components. Symptoms of the DTC P0235-17 can manifest in various ways. Drivers may experience poor engine performance, characterized by reduced power and sluggish acceleration, as the engine management system fails to optimize air-fuel mixture due to erroneous boost pressure readings. Additionally, there may be an increase in fuel consumption, as the engine may run inefficiently in response to inaccurate sensor data. The check engine light will likely illuminate, alerting the driver to a potential issue that requires further investigation. Recognizing these symptoms can aid in timely diagnostics to prevent further damage. The first step in troubleshooting the DTC P0235-17 involves turning the ignition switch to the on position without starting the engine. At this point, utilize the Honda Diagnostics System, HDS, to examine the TC boost pressure sensor value. If the HDS displays a value greater than 4.49 volts, this indicates that the issue can be duplicated and suggests that the sensor is likely malfunctioning. This diagnostic step is important because it helps confirm that the problem lies with the boost sensor or possibly with the electrical circuit connected to it. Establishing a concrete failure state early in troubleshooting facilitates a more efficient diagnostic process. In the second troubleshooting step, the process begins with disconnecting the turbocharger boost sensor connector, which has 3 pins, 3P. You will then use a jumper wire to connect terminals 1 and 2 of the sensor connector. This action effectively simulates a sensor signal so that the next step can proceed. After establishing this connection, turn the vehicle to the on mode again and check the HDS for the TC boost pressure sensor value. Ensure that this value remains less than 4.49 volts. If the voltage is normal under these conditions, it indicates a high likelihood that the turbocharger boost sensor itself is faulty, necessitating its replacement. Thus, This step is critical for isolating the sensor as the source of the problem. In this step, the focus shifts to conducting an open wire inspection for the circuit connecting the turbocharger boost sensor and the powertrain control module, PCM. Begin by ensuring the turbocharger boost sensor connector and the PCM connector B101P are both disconnected. Following that, perform an open wire inspection for the P3 and SG2 circuits. A multimeter is used to measure the resistance in these circuits, which should read less than 1 ohm for a normal condition. If either circuit shows higher resistance or an open condition, it indicates a fault in the wiring or connections, potentially leading to the high voltage signal detected by the PCM. Thus, effectively performing this inspection is essential for determining the health of the sensor's connections. The final step in troubleshooting the DTC P0235-17 involves a thorough inspection of the PCM itself, as previous checks have shown normal conditions elsewhere. This involves verifying the proper functioning of the PCM, which is the electronic control unit that oversees engine management and performance responses. Inspecting the PCM typically involves checking for fault codes, performance data, and ensuring that it is correctly interpreting the signals it receives from various sensors. If all previous components are found to be operating normally, then it indicates that the PCM may be the root cause of the issue and may require replacement. By confirming PCM functionality, technicians can ensure that they diagnose the problem accurately and undertake appropriate repair actions. Upon completing repairs related to the DTC P0235-17, it's imperative to conduct a final repair verification process. Begin by performing a test drive of the vehicle to ensure that it operates smoothly without triggering the check engine light. During this drive, closely monitor the HDS for any DTC reoccurrence and assess the TC boost pressure sensor readings to ensure they fall within the normal range. This confirmation step is essential to verify that the root cause of the high voltage condition has been effectively resolved and that the vehicle's engine management system is functioning as intended. Careful validation of repair outcomes helps prevent the need for further repairs in the immediate term. Preventive maintenance is critical in avoiding issues related to the turbocharger boost sensor and associated circuits. Regularly inspecting the turbocharger boost sensor, its connectors and associated wiring can preemptively identify problems before they escalate. Ensuring that all connections are secure and free from corrosion helps maintain electrical integrity. Additionally, keeping abreast of any software updates for the PCM can enhance performance and rectify existing issues that may cause DTCs. By establishing a routine preventive maintenance schedule, vehicle owners can significantly extend the lifespan of the turbocharger system and other related components. In conclusion, the DTC P0235-17 indicates a high voltage condition in the turbocharger boost sensor circuit, which can significantly impact engine performance. Awareness of potential symptoms such as poor acceleration and increased fuel consumption can prompt timely diagnostics and repairs. Following the structured troubleshooting steps ensures that technicians can identify and resolve the root cause effectively, preventing the recurrence of issues. Additionally, implementing a regimen of preventive maintenance can safeguard against future problems. By diligently monitoring performance and maintaining the vehicle, drivers can enjoy a reliable and efficient driving experience. Please like and subscribe to the channel. See you next time.